Thanks for the invitation and for having us. Both of us will give the talk today, so we will switch in between. And we want to talk a little bit about Kaggle. So what we want to talk about is what is Kaggle even? Yeah, I think maybe some of you know, maybe some don't. We will talk a little bit about our journey on the platform. And we will talk a little bit about, if we can spark your interest a little bit, how to start on the platform. We will have about half high-level stuff, and we will also go a bit into methodology to also give you a bit of insights for one of the recent competitions. Maybe this is of interest to you. So my name is Philipp Singer, and my colleague is called Dmitry Gordeev, and I want to start our presentation with this slide, which was in Tokyo last week, where Kaggle is having regular Kaggle days, they call it, which is a get-together of people of the platform. And you can see me here. It's easy because I'm blonde in a group of many Japanese guys. And Dmitry is hiding somewhere here. And I want to tell you two things for this slide. First, Kaggle has a really great community, and it's just nice to get into it. And second, we're super jet lagged, so if you fall asleep while talking, don't worry.
No beers.
No beers afterwards, yeah. So who are we? Both of us are working as data scientists at Unica Insurance Group. My background is I have a PhD in computer science at TU Graz. My history is also more in machine learning research and applications. And on Kaggle Competition, I'm a master, and I'm currently ranked 36 on the whole ranking. Dmitry is also a data scientist. He has a master's degree in data mining from Russia, Moscow. And he also has a lot of in-depth experience of ML applications, and he has worked a lot in banks. So for example, Raiffeisen Bank International. And he is the actual grandmaster, and he is currently ranked at 34th position. So what is Kaggle? Kaggle calls itself as your home for data science. So it's basically, as I showed before, it's a large online community of data scientists and machine learners. It was originally founded in 2010, and it was acquired by Google in 2017. Kaggle is maybe mostly well known for having data science competitions, which is the thing we will mostly talk about today. But it is much more. So it is a place for sharing notebooks, sharing data sets, getting into discussions. They even have courses and tutorials. So basically, it's a large community of data scientists. They also have what some people don't know. They have a free notebook infrastructure. So if you know, for example, Google Colab, it's very similar. So they have an infrastructure where you can use CPUs and even GPUs for free. We will get to that a bit later. How big is Kaggle? It is the most popular machine learning competition platform. They kind of introduced this notion of competitive data science. They have around 125,000 users on the platform. Overall, over this 10 years period, they have completed around 350 competitions. A competition, just to give you a scale, one competition usually has up to 10,000 users participating in those competitions. And for the top spots, there is some kind of prize pool that varies between 20,000 and 100,000. Sometimes for some very special competitions, it can go up to 1 million. So for example, now there is a competition about deep fakes, which has 1 million prize pool. Kaggle recently or yearly does some kind of survey of participants, which just want to show you some results to give you an indication of what type of people are on the platform. So most of them are in the age range of like 25 to 29, around this scope. So I guess very similar to the audience in this room on average. Where do they come from? There is a very large part is from the US. India has a very large user group on the platform, but also like Western Europe and Russia, and also some southern parts of America. People on Kaggle are very educated, I would say. So you can see here that more than 50% hold a master's degree, 20% a bachelor's degree, and even close to 20% a doctoral degree. So basically, a very, very large portion of the users are very educated. The next slide is maybe not the best for an R meetup, but it says which programming language do you use on a regular basis. Python is 9,000 people said Python, 800 R, but this is only R, yeah, but both, which proves the point from before that a lot of people are using both. Also is a large portion, and neither I don't really know what that means, yeah, but maybe on a regular basis, a lot of people actually use none of those. The next question is interesting. What programming language should an aspiring data scientist learn first? And here it's pretty clear that most people think nowadays it's Python. But knowing both, of course, is very valuable, and we will get to that on the platform. You can use both pretty seamlessly, and there are also quite a few top Kagglers who use R regularly. What we want to talk about mostly is competitions on Kaggle. Competitions are usually hosted by companies or research institutes. And so a company goes to Kaggle, says, look, we have this kind of prediction problem, we have this data, let's sit together, let's host a competition. Then this is hosted on the platform, and you can think of it being some kind of cheap outsourcing, because you have then up to 10,000 data scientists focusing on that competition with very low price money, because a consultant here in Vienna costs more than you need to pay to 10,000 competitors. And then you get a very nice model usually, and you can use that either yourself or kind of use the insights to improve your internal modeling approaches. The main goal in most cases is prediction. So that means the microphone is off, but did I click something?
Yeah. No. The battery.
Take the other one. And the backup.
Okay, backup is here, good. Yeah, so usually it's prediction, meaning you have some target, we will get to that you need to predict. The interesting thing about Kaggle is, which is also one of the main reasons why we got into it, is that there is a wide range of different types of competitions. So if you work in a bank and you do risk modeling, you mostly focus on risk modeling, but the nice thing on Kaggle is that you can really get in touch with very interesting and different types of domains. So for example, there's the classical financial domain, but there is also quite a few competitions about medical diagnostic stuff, for example, sports analytics, and various other things. There's also very different types of data in the competitions. There's classical stuff with tabular data, but there is also a lot with text, so NLP, a lot with image data, nowadays also sometimes video data, time series. So you can get really a broad overview of different types of data. But also the objectives are different. Mostly it's classification, sometimes regression, image segmentation, and there are also different goals of competitions. You have some kind of featured, what they call featured competitions, which usually are the competitions with prize money. Also research competitions usually have prize money, but they're hosted by some research institutes. But you also have a lot of competitions which are playground or in-class. This is basically you have a leaderboard, but it's constantly open and you can just try things out there and strengthen your skills. As with all modern online platforms, it has some kind of built-in progression system, so internet points with medals and ranks, and the top spots usually receive prize money. So usually top 3 receive a little bit of prize money. Kaggle is mostly about so-called medals. So you can win, if you do well in a competition, you can win either a gold, silver, or a bronze medal. It depends on how many teams participate in the competition. Nowadays it's usually above 1,000 teams, so top 10% get bronze, top 5% silver, and top 10 plus 0.2% get gold. So usually it's around maybe 15 people that, or 15 teams that get gold medals. And then you have your nice profile, which here shows your medals in competitions, but you can also get medals for posting a kernel. For example, if you have a nice R notebook or something that you want to share, a tutorial, people post that on the platform completely separate from the competitions. People vote on those notebooks and you can get medals, and you can even get a grandmaster just in kernel category. And discussion, you can also discuss, so there are a lot of forums, you can get points, you can get the gold medal by posting a meme, but you can also contribute and participate in the platform completely separate from the competitions. And nowadays there's even a fourth category, very recently, which is posting data sets. So how do competitions usually work? This is the classical case of a prediction competition. You get provided some labeled data. So labeled meaning you have the target of the data, that's your training data. And then you have basically two sets of test data, of unlabeled data that you need to predict. And this is called the public test data set, which is usually a smaller portion of the whole data set, and a private test data set. So you develop your model on the labeled data, you do some cross-validation here, you develop your model, and then you use the model and predict the labels of the unlabeled data. You upload your results, and during the competition there is a public leaderboard, which is the leaderboard based on this public test data. And then at the end of the competition, it gets completely rescored on this private test data set, and this is what then the actual end score and the end leaderboard is how it is determined. Think about this: if you develop a model in your company, you deploy it, you have this as completely unlabeled data, you observe it over a few months, and you see how it fares. And here, this is how the end score of the model is determined. Coming back to us and our journey. So we started on the platform pretty much a year ago together. Dmitry did it before already, a competition. And we started a year ago, and we used a team name. So we call ourselves the Zoo. The Zoo, the reason is because we have in our company some virtual machines, and as a good nerd, or however you want to say it, calls the machine by some name. We called it by some animals. So that's why we decided we are kind of the Zoo. I myself had little experience before on Kaggle, and we participated until now in the last year in 7 competitions. Why did we start on the platform? Basically, based on some of the main reasons that many of us have here. We have a lot of business problems, but it's kind of hard for us to either try things out, get data in a quick manner. And specifically, we started with having a lot of textual data problems at work. And there was a nice competition, I will just tell you in a second, where we just wanted to try out new state-of-the-art methods in area of deep learning, and that's why we just decided to start. Things worked out way better than we expected, and then we got kind of hooked to the platform, and we really got into it and continued to compete. And yeah, our goal has always been to diversify competitions for reasons of learning purposes. So we didn't only focus on text data, we also wanted to get in touch with image data, with certain tabular data problems. So that was always our main goal, to diversify our learning experience. This is roughly our journey over the last year. You can see here that we did pretty well. We not always did it only alone, but we had other teammates. I will go very high level through 4 of these competitions, and Dmitry will go more into detail in this previous competition, which is still not final scoring. You can see it here. There's no gold medal here yet, but we hope that this will go well. But Dmitry will tell details about it. So as I mentioned before, we had a lot of textual problems. So we started with this competition actually really a year ago. I remember me sitting next to the Christmas tree doing some Quora insincere question classification. Quora is a platform which is maybe way more known in the US, but it's a question answering platform. So if you know Gute Frage or something, it's a bit similar. And their task was they had 1.3 million labeled questions, and they wanted a model that can predict whether a question is sincere or insincere. So there is, of course, a lot of trash and spam on the platform, and they usually go through some manual labeling and reporting, and they also had some previous models, but they wanted to have something that can automatically detect it. So I can see you already read some of those. So we had a lot of fun reading through these questions. I mean, this is a valid question, yeah, and it says this is sincere. But there is like really fun stuff, like how come Trump is so stupid? Of course, that should be insincere. Is it possible for a vegan who does CrossFit to go 10 minutes without telling someone about it? Maybe not the most sincere question. Every time I slap myself in the face, it hurts. How can I prevent this? Well, maybe it is sincere, but at least the people labeling the question thought it's insincere. So overall, there were like 6% insincere questions. It was evaluated with F1 score. There were 4,000 teams, and what was interesting about this competition, so some competitions you need to run the code on the platform, so you're not allowed to basically fit and predict somewhere on your own infrastructure. This gives everyone the same fighting grounds, I would say. And in this case, you had to run it on a GPU kernel within 2 hours. So you have a whole infrastructure where you can run it, and your whole code needs to run in 2 hours, training the whole thing and predicting the whole thing. And everyone has exactly the same infrastructure, which is nice in this case. So not in this case, more computing power cannot win your competition, but sometimes they do these kind of competitions because sometimes also companies want a bit more simpler solutions because they can even be beneficial to their business value. And to our surprise, we won this competition. We were really not expecting this, and this is basically where we started to get hooked. As I said, I will not go through all the solutions, but basically here the solution was classical deep learning model on text data, which these kind of models really shine on these shorter text problems. It was a recurrent neural network, an LSTM model with pre-trained weight embeddings. So not going into detail here, but just to give you the scope. And actually over the last 1 or 2 years, a lot of state-of-the-art methods have been done in NLP. So maybe something like BERT, if you have heard, would fare here better. But in this case, it was this 2-hour limitations, and we got a really nice, solid solution. And we were, of course, really happy. Next competition was, okay, let's do some tabular data. Was Santander, a bank. And they wanted to know which customers will make a specific transaction in the future. This is still, to date, the largest competition ever on Kaggle. The reason is the data was kind of limited. It was structural data with, I think, 200 features. It was not too large, and that usually attracts quite a lot of people. The data was like 200,000 transactions, and the duration of the whole competition was 2 months. This is a usual time frame these competitions run. You can jump in anytime. You can also jump in 1 week before the end. And I could talk about this competition for a while because it was a very weird competition. They had like 200 features which were completely uncorrelated. So no feature was correlated with each other. It was anonymized. So we did not know what the features were about. Maybe they ran something by mostly AI, but it was very interesting data. And yeah, in the end, our solution was a combination of gradient boosted tree, which is usually used in this kind of tabular competitions nowadays, and a neural network. We ended here 7th. You can see here, this is the interesting mark, which tells you how much you moved from public leaderboard to private leaderboard. So the public leaderboard is based on this public test data throughout the whole competition. And then this is the final scoring. I think this is the only time we move down, but not too much. In some competitions, we will see this in a second, there is like a large shakeup here. Yeah, but you can see here, the scores are like, this is area under the curve, yeah, and you can see us from the prize money is on the 4th digit, and to the top is on the 3rd digit, yeah. Next competition was earthquake prediction. So now we wanted to do some time series data. You can call it time series, I guess. It was hosted by the Los Alamos Research Institute in the US. And the goal was to predict the time remaining before laboratory earthquakes occur from real-time seismic data. So what they do is they have a laboratory and they run some simulations in order to kind of accurately simulate how real earthquakes behave. And then they have some kind of microphone and they record the noise level. And then you have here the seismic behavior, and the earthquake occurs here and here. And you need to predict at each segment, without knowing the history, how far is it away from the actual earthquake, so time to failure. The data looks really large in the beginning, but it actually, this is a single data point on a very short Hertz scale. Or large Hertz scale, and in the end it was only split into segments, then 4,200 training segments. There were 4,500 teams, and our final solution only took 30 minutes. The trick was to use features which kind of measure the stability of the signal. So close to the failure, you have very impulsive and tremor-like signals, and with some time series features you can measure that. And in the beginning you have very like tremor-like signals. This competition we won. Here you can see we had a really large team, 8 people. We had a bunch of people from the US. Actually another guy from Vienna. Yeah, and here you can see this jump from public leaderboard to private leaderboard. So this is what people on Kaggle call a shake-up. You can see this guy jumped 1,500 spots. This guy, we jumped 350 spots. We had a really good idea of how the private data looks like, so we kind of expected to jump, but not to first place. But that shows that usually people who just take the public leaderboard as kind of an estimate of how well the model works have real problems. So you really need a strong cross-validation setup and really need to judge your model mostly locally. I think the final that I will present now, afterwards we will switch to Dimi, is now we had text, tabular data, time series data. We have never done before image data, and image data is super hyped. Everyone is focusing a lot on image data the last few years, and specifically deep learning models have made a huge step in that area. So we chose another competition, which was blindness detection, and I will show you in a second. But basically the idea was you want to detect diabetic retinopathy to stop blindness before it's too late. And this is actually the leading cause of blindness in the working age population. So people who have diabetes are more likely to get this diabetic retinopathy, which can lead to blindness. We had only 3,600 retina images from Indian population. We had to classify it into 4 categories. I will show on the next slide. There were 3,000 teams. And you can see here, first time very interestingly, way more evaluation images in the test dataset. So this is how you classify these 4 categories. You have like normal, which is no retinopathy, and then you have mild, moderate, severe, and proliferative. And each different category has different indicators. So if a doctor looks at these retina images, he or she knows if I see these type of blood vessels here in this shape, if there is some problems with the blood vessels, if there's some problems with bleeding, if there is some scar tissue, even a detached retina, you need to classify it differently. And this is how the images look like for us after we pre-process them. So you have this kind of image of the retina, you have here the optical disc, and you have the blood vessels. In this case, what nowadays people use is pre-trained image models. So this is really cool nowadays that people have already developed image models for large scale types of problems, and they're pre-trained. Pre-trained means they are already trained on large image corpora, which is called, for example, ImageNet, or even Instagram. So these are the 2 most popular data sets that these models are pre-trained. So think about having all Instagram images, training a model, and then it already knows a lot of the general structure of images, like circles, rectangles, colors a bit. So, and then you take these pre-trained models and you just, what is called fine-tune it on your task. So you just, and then you can actually work with this little data. So you just take the pre-trained models, you fine-tune it on these 3,600 images, which are specific to your task at hand, and then you apply it to your evaluation images, and it works really well. That was for us the first time we really tried these kind of things, and it works so surprisingly well that it's really nice. And if you have any business problems, nowadays with image data, you don't need that many labeled data. You can really utilize all these pre-trained models. So also there is a lot more detail to it, but that's kind of the general idea. We got here 9th, so still gold, which was important to us because first of all it was the first time of us doing image data, and Timmy got his Grandmaster title here, so he has the yellow stars. But in general, this is a very interesting type of competition, and very happy to achieve 9th here. And now I will hand over to Timmy, who will go a bit more into detail about the previous competition.
Thank you. Okay, let me jump into more details of one of the competition. It is the most recent one we took part in. It is still ongoing, and it was an NFL competition. Yeah, we have no idea how NFL works, to be honest, but we decided to jump into this one. We were looking probably as these guys in the beginning of the competition. The reasons why we did that was, as Philip mentioned, we were like trying different stuff. We tried one another, and here we saw, okay, sports analytics, something interesting to try out. Secondly, you never know what skills and experience would work, what you're going to be applying to like sports analytics, or what sports analytics will teach you so you will apply to, I don't know, insurance business in the end. And I will show you how it works actually. In this competition, it was a good example of that one. And third, and probably the most important reason we had, is because there was nothing else interesting on Kaggle at that time. So we jumped into NFL, and the first question we had to answer was, what the hell is going on here? When I was a kid, I had a video game with NFL, so I knew a little bit but that's where my knowledge stopped. So, but we need to know what's happening and what are we actually doing. There are two teams on the field. There's a ball over there. It's hard to notice, but I have like a red circle over there. There's a ball. They start playing, and the blue team is supposed to has to carry the ball further to the right-hand side in this example. They need to carry it for at least 10 yards, as we can see. Anyway, what did we have to learn here? There are different people on the pitch here. QB, there's this guy over here. He is the most important guy on the pitch. It's a quarterback. This guy receives the ball in a split of a second, and then he decides what to do with that. He has actually two options, as we learned. First, there are two runners, one over here and the other one down here. WR stands for wide receiver. These guys are trying to run as far as they can, so quarterback will pass the ball like in the movies to them, and they will catch it, and they will get further on the pitch. And this is actually not what's going to happen here. We're going to be looking at this guy who stands still just behind the quarterback. He's going to receive the ball and just like rush through the defense. The whole competition was about like exploring these types of plays. So forget about the guys running over here and quarterback passing to them. Now I'm going to jump what's going to happen in like 2 splits of a second. Quarterback received the ball, and then he just gave the ball to this RB, which stands for running back, I think. It's his role, and this guy is supposed to somehow carry the ball as far as he can. As you can see that there's a defensive guy rushing to him at the moment, so he has to try to avoid to get tackled. That was the data for the competition. So what we had was pretty much like this picture, but digitized. So we have a play. We have 22 players, 11 at each side. We know where they stand at the moment when quarterback gives the ball to the rusher. What are the speeds? What are the directions of the movement? And we know the outcome, how far he's going to carry the ball. What we have to do is to predict how far he's going to run with the ball, given the beginning of the play. So that's the input, and the output is where the whole play is going to end. They had several reasons why they tried to do this analysis, including like exploring types of the plays, what works or not in American football. Also, they're curious about like exploring new statistics describing the quality of the play, how well a player did in that or in a particular match or in a particular play and so on. So they were quite active on Kaggle with regards to feedback about the competition, stuff like this. Now the competition, it also had an interesting timeline. There were kind of two phases. Phase 1, when the competition started, it started over here, end of September. They had the data they started collecting the data relatively recently, at least in this shape. So we had 2017 season, 2018 season, and they collected September of 19th. Basically, the season lasts for 4 months, from September to New Year's, basically. They collected September data. They gave us the label data for 2 previous seasons, and we had to predict what was happening on the plays from September 19. I have bugs over here. The competition lasted until end of November, so it finished 2 weeks ago, sorry. At this point, we were supposed to submit our models, so everything got frozen, and they started collecting the data as it is. So they're still collecting the data as I speak to assess our models. This way, they excluded any possibility of cheating whatsoever, because, I mean, if you're somewhere here, you can potentially download the data from September because it happened in the past, but the models were frozen, and our models are being rescored over here to get the final results. The final leaderboard will be based on December data, and there will be 5 rescorings. So every week they're going to extend the data, score the models, update the leaderboard. So it's supposed to be also fun for us. Every 5 weeks have a sleepless night, refreshing the leaderboard because you never know when they're going to update it. They had 2 updates, so we have 2 weeks out of the 5. We're going to have the final results like 5th or 6th of January. So far, we're standing over here. They will have the 3rd update tomorrow in the evening. But so far, we have 2 weeks of the data, and we're at the top. And we're at the top, but let me brag even more. Look at this chart. These are top 50 teams and their score. The more to the right you are, the better. So this is 50th place and so on. You see that there's like a little gap between them. The 5th place is quite better than the 6th one. This is the 2nd place, and this is us. So we're very confident that we're going to be either first or something is going to break and we're going to be out of the leaderboard. There are 2 of the outcomes possible, I believe, in this case. Anyway, let's go back to the competition, and I will explain what we did and why we're so cool over here.
So you already spent the prize money, basically.
We have it planned. Yes, yeah, we have it planned. Never do that. Never do that.
Well, you should mention the story of the
That was a story. Teaching us never to think that you won the competition. I mean, because that was like this on public leaderboard. We were like very confident. We were like, yeah, we got this. Guess where we were after the 1st week of the data? Oh, actually, I gave you the hint. We were not on the leaderboard, basically. They ran it, something didn't work for us. We got nervous, we got like really pissed, we contacted them. They discovered a bug, so they reran it and we came back on the leaderboard. So the past week was quite stressful with regards to that, especially if you planned the winning, if you planned how you spent the winning money. Anyway, so let's jump to the competition. So more technical details. That's the data we had. The important part of the data. So we had a play. This is what they call this kind of configuration on the field, and we have 22 records per play. I marked the runner over here. We also have this information, and like basic configuration of where everyone is standing, X, Y, the speed, acceleration, orientation. This is the degrees, where the direction a person is looking at, the direction a person is moving. Yard line and yards, basically. This is where the game started, and this is how far the team advanced. So the last column is what we're supposed to predict. We had tons of additional fields, including player names, position, age, weight, stadium name, wind direction, wind speeds, type of turf, temperature, and whatnot. Spoiler alert, direction of the wind is not important. So what do you do with this data usually? And like that's how we started basically. That looks like tabular data, so you do some feature engineering and you try to figure out what is important to predict whether this guy with the ball will carry it as far as it could, further than in a different situation. What is important and what we tried and everyone else tried was like the speed of the rusher, acceleration, and like projections of how fast he's advancing like towards the touchdown zone, like distance to defenders, and if you assume like the closest defender is gonna tackle the rusher, how much time they need to kind of meet, distance from other defenders, defense spread. Some people do that, like how spread the defense line is, how spread the fence line is, distance to quarterback, stuff like this. So that's kind of an endless list because you can try and try. There are like quite a lot of combinations you can try to do and try to guess what would work. These were, I think, from the discussions like the most popular and the most successful variables. So what you do feature engineering, you generate all those features, then you push it to the model,
Usually it's boosting trees. These days, LightGBM is the most popular. Back in the days, it was XGBoost, but basically it's the same thing. Some people tried neural networks, also worked. We tried like few of those, few others as well. Then you either select the best model or create a blending ensemble and so on and so on. As you can feel I'm rushing through it, it doesn't really work. We tried that, we advanced a little bit on the leaderboard, but that's not the way to go. There are several reasons, I believe. Well, because you're limited to whatever you're going to create out of this configuration. You have to think, okay, what this might be important, the other thing is important, and you're kind of limited to what you're going to come up with. You have 21 players, excluding this rusher guy, and you have to kind of use this information. So you aggregate them, maybe order the players. So you're like, okay, let's calculate how far is the closest defender, how far is the second closest defender, or maybe order them in a different by different parameter or something like this. So you make a lot of arbitrary decisions which might not be optimal, and you get kind of stuck there. And in the end, top teams did not follow this approach. Probably many of them, including us, tried it, but it didn't work out. What did they use? They used transformers. This is a very interesting thing because the whole thing with transformers is coming from a completely different area. I will explain what this means in a little bit. The whole competition actually, most of the solutions of the competition came from a different area. And a lot of people use transformers, and we knew they were using them because there was a similar competition a few months before that. Similar in a weird way, because that was a competition where you had to predict electromagnetic features of a molecule given the structure of the molecule and distances between atoms. First sight, like, it has nothing to do with NFL. Well, indeed it doesn't have anything to do with NFL, but the data itself is very similar, and successful teams try that. To tell you more about that, let's talk about natural language processing, because why not, right? Stay with me on this one. This one is important. This is what we did on Core, and this is how text analysis usually works. This is how people used to classify sentences. You have a sentence, I love my new iPhone, smiley face. First thing you do is you do so-called word embeddings. So instead of, you replace each word with a vector of values. There are like pre-trained embeddings, you don't care about how they're derived, but you just have them, they're given. So you replace each word with a vector of values, which represent kind of a meaning, so the closer words are closer in this space, which is really cool and you can reuse it. And then you work with kind of a sequence of vectors trying to come up with a classifier. You do convolutions. In this example, you do convolutions over 3 words. So you have a neural network which looks at 3 subsequent words and trying to figure out if there is like something valuable out of them. It runs over all 3 words of a sentence, and then you pull it together, do some magic, and you predict the outcome. It is quite cool, and besides recognizing that there is a word in the sentence, you also can recognize certain phrases, and increasing the size of the window can increase benefit. Which is cool, but you cannot incorporate like long distance words. So if there's one word in the beginning of the sentence which is relevant for the end of the sentence, you cannot capture that. So people came up with transformers, which is a way to do that. So transformer itself is a very large neural network with like not only multiple layers, but also like 2 stacks of those multiple layers. One is called decoder, another one is encoder, which is not important at all. What is important is that they introduced the mechanism of self-attention, which is shown on this particular example. The animal didn't cross the street because it was too wide. We want our model to recognize that the word it is about the street and not the animal itself, because it's actually quite tricky, because if I would have replaced because it was too tired, for instance, then it would have been relevant to the animal, not the street. So this cool mechanism is quite heavy and it requires quite a lot of data to learn, but it learns those connections between the words based on the meaning of the words. So that was quite a breakthrough this year with regards to algorithms of automatic understanding the questions and answering the questions, those type of things. So what people did, jumping back to NFL, they said, this is an example of one of the solutions, they said let's assume that we're using transformers and the words are players basically, and the embeddings are the descriptive vectors we have where the player is, what is the speed, what is the acceleration, and so on and so on. That's one of the top solutions. So this guy basically ordered the players, so there was rusher, 11 other offensive players, and 10 other offensive players and 11 defensive players, always in this order. And he ran it, he assumed it's kind of a sentence, and ran quite heavy transformers on top of each other. So the model recognizes kind of the dependence between the players, so interactions between the players, what is important, whether it's important that one offensive player is over here and two defensive players over there, and so on. That was, I think, like second or third publicly reported solution, but if you go to the page of the competition and look at other solutions, you will see them everywhere. Like out of the 10 solutions, I think 9 was about transformers. And this is quite a cool thing. That's an absolutely NLP related idea, which they were applying to first physics, and now we're doing sports analytics with NLP technique. But we did something different, of course, otherwise we wouldn't have been that far away. We actually applied rather logic than hardcore neural networks here. Now we'll quickly just go through the solution without jumping too much into the details. That's the picture. We have a rusher carrying the ball and 11 defenders. I'm actually I faded away the offensive players. Let's forget about them. We have a guy who's carrying the ball who needs to run further, and there are like 11 other guys trying to stop him. Our idea was there's no kind of team play, there's no interaction between the defenders. Each of them is just trying to stop the rusher. That's the ultimate goal. So let's forget about like some complicated logic of interaction between those players and just look at each pair. Rusher, one defender, assess their locations and speeds relative to each other, proceed to the next one, and so on. Basically, I'm describing a convolutional neural network, the one I showed before, but with taking only one defender at a time. So that's what we did. We said, okay, let's calculate relative speeds, relative locations, absolute speed, and do just a convolution over all the defenders, and then do the usual things. That worked really well. We're forgetting about like complicated attentions, graph neural networks, and so on and so on. We do the basic convolutional neural network. That works quite well. Now we need to recall that we also have offensive players, the blue ones, and we apply the same logic. Actually, each offensive player will try to stop the defender from tackling the rusher. So if you take a single defensive player, you should look around on all the blue ones and do the same thing. Let's assess their relative location, relative speed, convolute, aggregate. That makes it look a little bit more complicated because we have like pairs of players, offensive, defensive players, but it looks like kind of a, well, it's a tensor matrix times the positional things. We do the same convolutional pooling and it's done. So putting those things together, this is basically our solution. Yeah, with some like complications of how we tune that. And that made a difference, and that made a very interesting difference, because this model is way more straightforward, way simpler, way faster to fit, and way better accuracy-wise. So this is what made it so special to us, and this is what made it what made such a big difference between us and being in second place. There were, of course, other tricks and things we did to succeed, and if you go to Tango Competition webpage, we already posted the solution with a description. We describe basically the logic of what we did, technical details, and other tricks and so on. So there is a link, but if you go to Kaggle, find this NFL competition, it's going to be easy to find the description of what we did here. Now I'm going to pass the microphone back to Philip to proceed, because I'm over with this competition. And we'll have some general words about what might be your experience in Kaggle, how you can start if you're interested, and so on.
Thanks. And don't worry, we need only 5 more minutes. So now what we have shown you is a quick overview of some of the competitions we have done and a more detailed overview of the recent competition. And I think we chose this because we are definitely the most proud of this solution, and we really hope that it works out in the end. So why should you start on Kaggle? There are, I think, several reasons for that. First of all, and I think most of you know that, is that doing is the best way to learn. So if you want to learn something, if you want to learn a new technique, you can read a book, you can watch a tutorial, but as soon as you actually do it, you really learn it. And Kaggle is a great place for that, because it has, as we showed, a lot of different types of problems. And the nice thing is, you have, for historic competitions, top people usually post the solutions. You have kernels, you have notebooks, you can just copy the solutions, play around with it. You can even, what you can usually do is you can make a late submission. So even if the competition is already over, you can, without any hassle of competing, you can just submit your solution, see your score on the leaderboard without ever needing to have any concerns about competing in a live competition. It can let you get in touch with data and use cases outside your main domain. And as we just showed, this is really valuable, because if you see some solution in a completely different scenario, you might apply it to your problem at work or at your business, wherever. And what we really also showed is that domain knowledge is the least important thing. Usually machine learning experts win over, or are higher rated, higher ranked as real domain experts. And of course, this NFL competition was a good example, because there is a whole community of NFL sports analytics, and they do an awesome job. But it was not enough to just generate features here and run something through a light GBM. You really needed to think about the problem from a bit of a different perspective. Of course, working with a domain expert can always be valuable, but usually just being a domain expert is, from our experience, not enough. It can allow you to keep up with state-of-the-art methods. You can learn from others. This is really, really important. It can also give you a bit of a self-assessment. And, which is also important, there is hardware and software provided by Kaggle, so you don't need to care about anything. You just open the notebook, you have a full environment, you just run your stuff in there. You cannot run GPUs forever. People did some Bitcoin mining a while ago, so they limited it, but it can give you at least enough resources to get started.
And you can do it in R and Python, or
you can do it. In R and in Python. So you can choose in the notebook just R kernel or Python kernel. Both works perfectly fine.
And you can run reticulate in the R.
Sorry?
You can run reticulate in the R environment. You can run the Python code from within R.
I don't know, but probably you can. Yeah, but I mean it's basically a Linux Docker container, yeah, and a notebook. So you can usually run even Linux commands. You can even, I think people even make it work to run C code and so on in. Yeah, but usually it's a Python kernel. Like if you
I'm not sure if you're using Jupyter or something. It's basically a Jupyter notebook, yeah, with an R kernel and a Python kernel. Yeah, here is an example of a notebook. You can somewhere here in select if it's an R kernel or a Python kernel. It's very easy to start. So, for example, if you go to any kind of competition, you have already a list of publicly available notebooks, which you can just copy. It's called fork. Yeah, you just fork the notebook. You have all the code in the notebook, and you can just run it and play with it. You can see here, this is a kernel with GPU off. Yeah, so CPU kernel. You have only cores. You have 4 cores here. You have 16 GB of RAM. You have some disk space, and you can run it 9 hours. You can run it either interactively, or you can click on commit. That is basically running the script, and you can see the output afterwards when you come back. Yeah, and there is a lot of stuff out there. There's usually also a starter kernel to just get you going. So I think it's very, very beginner friendly. So you can really get really good scores also by looking at other code and learning from others. And this is actually one of the most important things. So how can you start on Kaggle? As Wayne Gretzky or Michael Scott said, you miss 100% of the shots you don't take. So don't be afraid, just do it. Yeah? I was also like, I signed up to the platform 7 years ago, I think, and I only started a year ago, because I also was, to be honest, a bit afraid, like, oh, you measure yourself with others, what if you fail? This is called actually self-handicapping behavior. So you're not doing something because you're scared that your self-esteem is hurt, because you're suddenly seeing how you fare. But this is completely irrelevant, because the main point is you don't get rich here by competing. Yeah? The salary is a very bad salary. But you can learn a lot of stuff, and you can really also get in touch with a lot of different types of problems. And you also gain points regardless of the result. So even if you end up last, you get some points. No, I mean it's and no one ever will judge you on the platform. This is very, very important. Like, no one will ever say anything negative. There are a lot of top Kagglers who have ended at the end of the leaderboard. So it's not something that anyone needs to be afraid of. They are also getting started competitions. So there are also competitions like most of you might know, like the Titanic dataset, which is a very classic dataset where you need to predict if the people on the Titanic died or not, based on some features in which cabin the person was and so on. And this is just a constantly ongoing competition, but a playground competition. So you can just try this, how it works out there, submit something, see the leaderboard, and get a feeling for the whole thing. Pick a competition that sounds exciting to you. Don't be afraid to pick one where you have no prior experience, because that's a nice thing. You need to read up a bit, you need to research a bit. It's nice to learn new stuff. The most important thing is research similar previous competitions and read solutions. And people are really, it gets better and better with every competition, I feel like. So in this NFL competition, out of the top 20 solutions, I think at least 15 posted their solution. So you're not required to post it, but the open sharing is very, very valued on the platform. So you can read up on a lot of previous solutions and also follow published notebooks and discussions. So if you take part in a competition, it's usually you need to really be up to date if you want to really compete there. So you need to read what others are doing. Some people are sharing more than they want to share because they write something and it has some hints in it. So it's really a bit also about psychological warfare. It has everything to it. And notebooks also, where people, like, someone posts a notebook with some feature engineering, you can copy that, try out which features work in your solution, etc. Yeah, and learn from the community. That's basically what I mentioned. Here in this example, you can see from the NFL competition, a lot of people posting what they did, 4th place solution, 3rd place, 8th place. It's basically a discussion going on where they describe. This guy even claims his solution was public from the beginning because he took it from a previous competition. So there's a lot of interesting things to learn just by reading to get a feeling of what people do. And there are all the notebooks, yeah, so you can see here notebooks, which are all the notebooks that are published. And you can just look at them, copy them. You can see they are even discussed. So it has really a lot to it. Yes?
There is even on the screenshot one R notebook.
Markdown, RMD.
Yeah, RMD.
Yeah.
By accident.
I didn't filter it out.
Yeah.
How to approach a competition? Yeah, as we said, choose a programming language. It's usually Python or R. They had a while ago also Julia, but no one was using it, so they focus really on Python or R nowadays. Understand the problem setting, get a feeling for the data and the metric. The metric is usually very, very important to understand what is actually the KPI. Is it area under the curve? Is it some accuracy, etc. Then you usually start with explorative data analysis. You can be really lazy here because there are people who care a lot about their kernel medals and points. So basically after the 1st or 2nd day of a competition, you have a lot of notebooks already dissecting the data from start to finish with plots, with statistics, and you can just check them and look at them and then continue from there. But of course, this is also valuable to do yourself because not everything is captured usually in these notebooks. And then what is usually a good idea is to implement a basic script, either from scratch or copying something from public, that does training and prediction. So think about reading the data, doing some simple features, for example, having a cross-validation routine, and then doing the predictions on the test data set, submit, see if everything works, and then you iterate from there. We have not talked much about that, but thinking about a robust cross-validation setup is one of the most important things, because it can help you to not overfit to some public leaderboard. It's usually very, very important to have something like this. And clever ideas of this cross-validation setup can even win you competitions like it did for us in the earthquake competition. Yeah, keep up with discussions and developments, and experiment a lot and iterate quickly. So if you have a simple script, it's very straightforward sometimes to experiment a lot. So let's say you have a kernel which does everything from start to finish. You start at night 10 forks of this kernel and you change one parameter 10 times and you run it overnight and see what happens. Yeah? This is sometimes a good idea because you need a lot of time to really go from a good solution to a very good solution. And there is often very fine-grained things that you need to experiment. So to give you an example, this is, Timmy calls it a Christmas tree, you call it Christmas tree, yeah? Of some of the development of our models in the previous NFL competition. So each of these dots is a notebook, and the edges are basically copying the notebook, so forking it. And you can see here that we have some kind of main path through the red dots to the final solution. This is what we finally submitted, but there are also directions that led to nowhere. But this is classic experimenting. You need to do a lot of it. And yeah. So with that, thanks for your attention. Hope to have motivated you a little bit and not overwhelmed you. But to us, it's still great fun to do stuff on Kaggle, and maybe someone of you is interested. If you have any questions, let us know. Thanks.
So thank you so much for this talk to Philipp and Dimi, and I hope we have a lot of questions. Not sure.
Maybe we don't.
Maybe we don't, because I forgot the event code again. Wait a second, but the final beer is near. That's for sure. It's on slide.
Yeah, they are few.
Go. And the event code was
VR.
ViennaR ERSTE.
Big V, big R.
Oh, there it is.
There it is.
But you need to.
I'll pull it up.
Maybe we need to.
I need to do this first, I guess.
So first of all, I really like the solution for the NFL journey. So for the NFL competition.
Yeah.
And what strikes me, I mean, it's a kind of a definition, if you call it domain knowledge or applying logic, as Dimi said. But I really like the approach, and I also understand why it's, so much better just by applying logic, having maybe a bit more bias in the model, but making the problem easier maybe for optimization. So you could also call it translating the problem better for the model. And so I really like that. And kinds of those things, it's not possible, I think, with AutoML, or what do you generally think of AutoML? Is it a threat to you? And also for the others, I mean, I'm already thinking that those two guys need more competition. So they seem so confident. And I mean, if you take one thing away, is really start Kaggle and, compete those guys.
Well, first of all, there are actually a few AutoML companies who are hiring a lot of people from Kaggle. So I saw some H2O stickers here. This is one of the company who hires a lot of people from Kaggle. Data Robot is one other well-known one. So it's a big thing. Google is of course also pushing it. You even have some competitions where they run some AutoML and you have AutoML in the leaderboard. So you can see how you compare to AutoML. The nice thing about AutoML is that it can give you some reasonably good result quite quickly. But the longer time you have, usually a good data scientist outperforms AutoML quite significantly.
One from the other because
A recent.
recent.
Then it will be ordered. This is ordered by uploads.
Yep.
Okay.
So maybe I'll try it. I'm sorry for this Slido setup. Please bear with us.
There's the AutoML question.
So we had the AutoML question, I think. So you talked about assessing model performance locally and not rely too much on the score in the public leaderboard. Mm-hmm. What is your approach for this?
There is no single answer to that. You need to understand the problem, and you need to really understand where there is a kind of leak. Yeah? So for example, let's say you have customers in your data, and customers behave very differently. And then having a cross-validation setup where you shuffle the customers between the folds, and you train on the same customer and predict on the same customer, it will fare very well because it learns already this customer behavior. So what you try to do, for example, is that you have always different customers in each cross-validation fold so that you never train and predict on the same customer. Just as one kind of idea of that. And you really need to think a bit about that, specifically in time series problems. This is more important because you also have like time trends. It's usually better to train in the past, predict in the future, because that's also how the test data then looks like. So there are a lot of things that you need to think about. There is like no single magic to it. But it's a very important part, and good Kagglers usually even take a few days, a few weeks to just think about how to set up the cross-validation. Because if you have a good cross-validation setup, I think you removed the slide from NFL competition, but in NFL competition we had a really perfect cross-validation setup where it was perfectly correlated with the leaderboard. And then you don't need to even submit something because you can be so confident in your cross-validation that you just focus on that and evaluate locally, and then be confident about it.
Very cool. Thanks. So there is another question regarding the time spent on the platform. So, considering your, your last wins and all the successes, so how do you manage that? And all those, maybe I think most of them were Asian competitors, or I mean, just based on the photo, it looked like.
Yeah.
So was it hard to find the time and the energy, and how do you manage that besides your, I guess, full-time job, and how does it work?
As Unica know.
They do know. They're actually proud of us. Yeah, people ask how much time do we spend on competitions. I always answer the same thing: too much. We spend quite a lot. Day-wise, we usually with NFL we made the mistake to jump into the competition at the very beginning. Never do that because you're gonna spend too much time on it. If you start the competition, the very smart thing is to, if you see that the competition started, this very smart thing is to wait. Wait for a week or two. People will start describing their solutions, their findings, and you can jump in really easy. The best suggestion on how to handle the time management is to team up. Probably that's the only thing I can recommend. Because if you have someone else, then basically the efforts required from you is halved. Other than that, if you're aiming really high, you need to try a lot of things and spend a lot of time. How do we split?
How to split the work?
How do we split work inside the team? And yeah, I think, do you have a general procedure of handling new competition and they go together? Our personal approach here, we do not split it because you never know when one thing will lead to another and so on. And we don't have like one of us focusing on feature engineering, another one on modeling. We started the whole thing to learn, so we wanted to learn everything. And in our team, and whenever we team up with other people, everyone is focusing on whatever he believes is important or promising. So it ends up like me thinking about feature engineering now and then realizing it doesn't work, but that leads me to an idea of like a different modeling approach and so on and so on. So it's really creative thinking, which is helpful when you don't have a split of like who's doing what in the team.
And and also communicating what you're doing is very important, yeah, because sometimes people, they try something, it fails, but they don't tell you they tried, and then you also try, but it's completely wasted time. Or even if you have some idea that you can't conceptualize fully, just talking with others, that's why it's so nice to work as a team, because then the other person can just continue this thought, maybe has a different direction to take it. So working as a team is always very, very fun, and also sometimes underappreciated. So also if you can team up with some other guys, you learn how they work and how they approach problems, and sometimes it's very different than what you do.
I have a very mean question maybe for the last one. I mean, you could also critique this Kaggle competitions and say, okay, it's kind of overfitting based on this, of course on the private test set, or how can you say that the model is really better, or is it also, or how much chance is also involved in these kinds of competitions? What's your feeling on that?
There are better and worse competitions for sure. There are some competitions where you have some so-called leak. Yeah? Leak means that there is, for example, some information somewhere in the training data which should not be there, but there are a lot of clever people dissecting the data from start to finish and finding some kind of thing that can give them a lead in the leaderboard. That's probably bad, but there is a lot of work in crafting the competition itself. It's not easy to have a good competition, so there is a lot of work going on before the competition by Kaggle and by the hosts to try to create a data set that is very, very good. You cannot always do something like with NFL. Here it was perfect. Like the data you actually score on has never happened before, so there is no way to cheat. But that's not always possible. And there are some, of course, you can sometimes criticize that a solution that plays 500 would be enough for your business, yeah. But the companies that usually host these type of competitions have usually already some business value for it, and then for them every digit also counts. Yeah? So if it's just something that you first introduce in your company, probably something simpler, faster is enough. But for those problems, oftentimes it's really a lot of business value, and there is small differences are important. Of course, there's also randomness involved. You cannot always get rid of it. So there is some. If you have a better random seed, you can be higher or lower, but that's part of the game, and you need to somehow also try to account for that.
We saw that there are sometimes 4-digit differences between like third and the fourth place. Surprisingly, like those distances which seem tiny, they remain on the private part. So basically, the models are quite stable, and the ordering there is sometimes a shakeup, but very rarely a severe one. So you see that those solutions which were picked by the top teams, they are robust, they are reliable, and score similarly on the data which no one has seen before. And that's my point, my takeaway with regards to like stability of the models and whether it makes sense to invest that much time and efforts into getting the fourth digit. It is there. It improves the fourth digit, and it is up to the host to judge whether it's important or not to improve the fourth digit. And with regards to like having heavy models and stacking, Kaggle is actually hosting nowadays. So very frequently there's code competitions where you submit the model, and you have time and resource constraints. So you can use only 4 CPUs for 2 hours, for instance, straight. So whatever you do, it should fit the timeline. You submit the model, and these days, like in the NFL, it is scoring the data which you haven't seen or which is not even here yet. So they're kind of answering to this critique, I guess, by doing this, what they call, they regularize the models by limiting the time and also by hiding the private tests, so it's completely isolated.
And just one tiny thing we didn't mention is you during the competitions you submit hundreds of models, and in the end you need to choose 2. Yeah? So this is also a very, very important part of the whole competition. So you need to decide which 2 models you think will fare the best on the private data set. So think about if you put a model into production at work, you also need to decide that. Yeah? So this is also something you learn, and then you try to find something which is rather robust and less random. So that's important.
And no doubt, we actually don't doubt that you really earned what you achieved, and you are a Kaggle Grandmaster, and I think you're close to becoming one. And to all the others, please challenge them. I mean, come on, how hard can it be?
Yeah, I don't know.
No, but again, big applause to Philipp and Dmitry.